Welcome to Loksatta Yashasvi Bhava. Children, in our last session, we have discussed all about the functional groups and the homologous series. Let us now study about the nomenclature of the organic compounds. The organic compounds are named by the IUPAC system, that is the International Union of Pure and Applied Chemists system. While naming the carbon compounds or the organic compounds, three things that we have to keep in mind is identify the parent hydrocarbon, then identify the functional group attached or the type of bond that is used here, and the third thing, the location of the functional group and the type of bond that is applied in the particular organic compound. Let us study this nomenclature with the help of some examples. The first one is the ethyl alcohol, that is C2H5OH. Here I am already telling you the name first, but in your exam only the structure and the formula will be given to you. You have to name a particular compound by following certain rules. Let us see what these rules are. The structure will be given to you in this particular form. When I say C2H5, so two carbon atoms are attached to each other by a single bond, and these two carbon atoms are attached with the hydrogen around it. One of the hydrogen atom is replaced by OH group. Now first identify which parent hydrocarbon does it belong to. For that we see or identify the number of carbon atoms that are used in this structural formula. Here we have two carbon atoms that are there, and to one of the carbon atom OH group is attached, that is the functional group alcohol, which means it belongs to the ethane parent hydrocarbon. And because there is OH group attached, which is the functional group, and we have already discussed that OH group, it is been recognized as OL, or we put suffix as OL. So ethane becomes ethanol here. While writing by the IUPAC system, we also note down its location. OH is attached to the first carbon here. Now while numbering the carbon atoms also, we begin numbering with the carbon atom to which the functional group is attached. In this example, OH is attached to this carbon atom, so we start numbering. This is carbon 1, this is carbon 2. So while naming the organic compound, we write it as ethan-1-OL. 1 represents the location of the functional group, and OL is the suffix that is used for the functional group alcohol, and hence it gets the name ethane-1-OL. Let us see now the second example. The structure is having 3 atoms of carbon, 7 atoms of hydrogen, and 1 atom of bromine here. Now identify the parent hydrocarbon in this particular example by counting the number of carbon atoms 1, 2 and 3, which means it belongs to the propane in the series. Now identify the functional group here. The functional group may also have halogens. So bromine is one of the halogen. Hence Br is the functional group here, and it is attached to the second carbon atom. Hence it gets the formula 2-bromopropane, because bromine is attached to the second carbon atom here. Now let us see the next example. Count the number of carbon atoms in the given formula. 1, 2, 3 and 4. There are 4 carbon atoms, hence it belongs to the butane in the parent hydrocarbon series. Now the 2 carbon atoms are attached by a double bond here, and hence this butane becomes butene. The location of double bond is between the carbon 1 and carbon 2. So we select the lower number and hence we write the name of this carbon compound as but-1-ene. We also call it as butene. Again, here while numbering the carbon atoms, we see that we start numbering the carbon atoms which is closest to the double bond or the triple bond. Next example, here we have 4 atoms of carbon. Again, it belongs to the butane in the parent hydrocarbon series. Here we have a double bond between the 2 carbon atoms, so it is butene, but the location has changed of the double bond here. The double bond is between C2 and C3, hence we use the number 2 here. Therefore, it gets the name but-2-ene. Here E because it is a double bond. Butane gets changed to butene. The next example is with a triple bond C2H2. The 2 carbon atoms are attached by a triple bond. Now identify the number of carbon atoms and which parent hydrocarbon does it belong to. C2, that means it is ethane, but because it has a triple bond, this becomes ethyne, and hence the name of the this particular organic compound will be ethyne. So for each organic compound, we have seen that there are different rules that are applied. Basically, for the nomenclature, first is you identify the parent hydrocarbon by counting the number of carbon atoms. Next, identify the functional group or the double bond and the triple bond, and third, the location of the functional group and the double bond and triple bond. Now children, let us discuss some chemical reactions with respect to these organic compounds. The first is the combustion. Combustion is when all the hydrocarbons burn in air to form carbon dioxide and water. For example, methane combines with oxygen to form carbon dioxide and water. In the process, a lot of heat and light is given out, and hence they are all exothermic type of reactions. Then next we have is the addition reaction. When 2 molecules, the reaction in which the 2 molecules react to form a single product, which is a new compound that is formed. These reactions, addition type of reactions, takes place only in unsaturated compounds. That is, the unsaturated compounds get converted into the saturated compounds in the process of addition reaction. Let us understand this with the example. Ethene plus bromine. Children, you know that ethene means carbon and carbon atom is attached by a double bond. Ethene has formula C2H4. So 2 carbon atoms are bonded by a double bond attached with a single bond of hydrogen. This when added to bromine molecule. Now this bromine we are showing with respect to the atom, that is bromine plus bromine. It can easily cut the bond, this double bond, and get attached to each carbon atom. We know that the outermost shell of bromine, we have 7 electrons, and hence it requires 1 electron to attain stability. That 1 electron it will share with the carbon atom. With the result, both carbon and bromine will become stable, and hence this double bond gets converted into a single bond. So we get a new compound, that is 1,2-dibromide ethane. So we see here that a double bond is getting converted into a single bond. That means the unsaturated compound gets converted into a saturated compound in the process of addition reaction. Another example we can take here is hydrogenation of oil, where ethene combines with hydrogen molecule to form ethane. In the same manner, hydrogen molecule, each atom of that molecule will combine with carbon to form ethane, and hence it gets converted into a single bond. So again we see that unsaturated compound gets converted into a saturated compound. The next type of reaction is the substitution reaction. The reactions in which where substitution of one or more atoms in a molecule for another atom is taking place. Again, example we see, methane combines with chlorine in presence of the ultraviolet rays to form methyl chloride and hydrochloric acid. Now here we see that one atom of hydrogen from methane, it gets substituted by chlorine. There are two atoms of chlorine here. One atom of chlorine gets attached to methyl here, and hence it forms a compound called as methyl chloride. Hence it is called as a substitution reaction, because one hydrogen atom is substituted by chlorine here to form a new compound. Now let us see the other reactions of ethyl alcohol and ethanoic acid. First, the reaction with ethyl alcohol. When ethyl alcohol reacts with sodium, it gives a new compound called as sodium ethoxide, liberating hydrogen gas. Then reaction of ethyl alcohol with phosphorus chloride. C2H5OH reacts with PCl3 to give ethyl chloride and phosphorus acid. Now let us see the reactions with ethanoic acid. Ethanoic acid is nothing but acetic acid, that is CH3COOH. Acetic acid or ethanoic acid reacts with chlorine to form monochloroacetic acid, that is CH2ClCOOH plus HCl. Again, this monochloroacetic acid will react with chlorine to form dichloroacetic acid and HCl. Again, dichloroacetic acid will react with chlorine to form trichloroacetic acid along with HCl. Acetic acid also reacts with metals like sodium to form sodium acetate, and hydrogen gas is liberated in the process. Children, there are still more reactions that you can make of organic compounds. I would advise you to write down all the chemical reactions with respect to ethyl alcohol and ethanoic acid. Now from the entire chapter you will have to personally draw all the structural formulas of all the parent hydrocarbons, that is the alkane group, and prepare the homologous series attaching the functional group to each of the hydrocarbons in the alkanes, and find out for yourself the new compounds that are formed. And without drawing or without writing or without practice, you will not be able to do a thorough job for this particular chapter. So I advise you that you write down and draw all the structural formulas with respect to all the topics that are given in this particular chapter. You may refer to the article given in the Loksatta Yashasvi Bhava for all the details regarding this particular chapter.